I have sample tubes in a gloved hand here to bring the samples themselves up to body temperature, near body temperature. What I have here is a sample of eicosane on the left. It's a solid, and I have a sample of azobenzene on the right, which is also a solid. And in the middle, I have a sample that's a mixture of eicosane and azobenzene, which is a liquid when I initially pull it out of my glove. But as you can see, as it sits here on this metal that's been out at room temperature, you can see that the sample is freezing into the solid state. So what we have here is an example of pure sample, the eicosane, with a little bit of impurity azobenzene added. And that sample's freezing point, that eicosane's freezing point, gets depressed so that it can be melted at near body temperature. And so this is an example of freezing point depression. Other examples of freezing point depression include adding sodium oxide to silicon oxide to help make soda lime glass. Here at the Earth's surface, we add salt to water to help keep that water from freezing in the wintertime. The freezing point depression of the salt water is lower than that of pure water, and so it's harder for the water to freeze to form ice. They think that a similar process might be happening on Mars. There are salts like sodium chloride and sodium chlorate and other salts on Mars, and it is thought that maybe, just maybe, those salt impurities can depress the freezing point of water to the point that under certain conditions maybe liquid water can exist, but that's still an area of intense study. But that would also be an example of freezing point depression. And you can see that by now all of these samples that I have on this metal plate have turned to a solid.